welcome. I'm Charlie. This is my combustion chamber, combustion flame tube, boiler, steam system for my Tesla turbine. I'm not sure if you can see that in the background. I'm just going to be going around here, tooling on with this. Welcome, join me. It's not going to be too exciting. Just got any questions, I'm going to be on the side over here on my tablet. I can answer any questions. I'm going to do a quick check on the camera. Make sure everything's good. Mind me while I get these other parts of the system going. This is my first time going live. Not entirely sure how this works. Cool. How was the delay? Guess we'll get to see. Wow, that's a long delay. Alright. Well. Most recent updates, if you watched the last tooling video, I redid this whole base. I now have the upper header for the steam section. I don't think I had that done in there in the last video. I think I ended the last video where I was going to be making a new air fuel mixer for this, and now I have the new tri-clamp one. There we go. I was in the middle of something and I kind of decided, hey, why don't I try going live? If you're with me, say hi in the chat so I know you're here. Let me know if you can hear me well. Okay. Why are you not charging? There we go. Hey, welcome. Not sure who else is here, but let's say hi in the chat if you want to. So if you didn't go back and check it out, last time I left off with the long video, I had done the I reassembled the internal combustion chamber with the all stainless steel one. I now have added the header. I got a sight glass, and then I'm gonna have the spark plug comes in here. This will eventually get sealed off. I'm not pressurizing the boiler right now, so steam will just come out the sides here. Built a new air fuel mixer. Gonna be testing that here soon. I'm hooking up the propane tank. Hey everyone, let me know if you guys have any questions in the chat here. I've got my tablet going here. All right. So Right now I have a dual fuel system I'm going to be hooking up to this single throttle, I guess, needle valve. Right now this is going to be a pressurized fuel tank. I'll be able to put gasoline, waste oil, any kind of liquid fuels that go into this thing, and I'm going to pressurize it with air, and I can change it out. Now I'm putting a T in so that I can also run the propane with the liquid fuel at the same time. We'll be able to switch back and forth from them, or we'll run them at the same time. Did I just put that? I didn't do that. Okay. The fun game of where did that go? Did I really put that in here? No, I didn't. Oh, it's in here. I need to clean the table off. Hey, Mr. Right One. Thanks for commenting. If you got a chance to catch up with what I said before, let me know. If not, ask in the comment and I will re-explain on it. Yeah, I like organized shops too. I'm not very great at it when I'm in the flow of things. You wouldn't believe how well I get stuff done still in the madness of all of this. I know where everything is. Like literally, I have a virtual version of this garage in my head, and every tool, everything that's even in random spots is still in my head, stored and saved there. I need to put. I don't have two more of these. I did already use them. I'm putting check valves on the two different fuel systems I'm doing here. Yep, there's no I in team, but there sure is an ME. No, all jokes aside, I could definitely use help. There's just so much in the works here between the high pressure, high temperature, combustion and steam, and then the low pressure vacuum systems I'm working on, and then the Tesla fountain that's in the background over there, which if you guys didn't get a chance to see it, this thing's cool. Big old column. We're going big. But yeah, if you didn't see before, I'm working on the fuel system. I've got a pressurized fuel tank for waste oil or gasoline or any kind of liquid fuels, and I'm going to have a propane tank here hooked up at the same time. I'm doing a T so I can have a dual fuel. Make sure they go in the right direction. Okay, so I've got that's gonna have to come out. So I've got a bunch of different fittings. This braided goes from compression to, and I've got a compression fitting to NPT into here. So I'm gonna have to change this out and change this out. Yeah, I'm gonna have to change this out. On the note of the temperature of the room, it is really nice in here in the winter with all the stuff. because it does help for insulation. This is the first year I had actual heat. Been working on this garage workspace turbo shop for like 7 years or 6 years now. 2 winters ago I finally got insulation in here. This last winter I finally got heat in here. Yeah, so on the note of something I don't think I've been had a chance to really explain on video format, but if you've been reading through the comments of a lot of the videos, I've kind of been showing the different texts or different parts of the text from Tesla's patent. In the GB186 the combustion plus steam turbine patent, I think a lot of people are getting confused that I've been working on the vacuum steam stuff, and now I'm also doing this combustion stuff, and I think a lot of people are missing the connection between the two, and I don't know if people realize that they're one system, one single system, that most steam systems already, most large full-scale plants go from high-pressure steam to a vacuum condenser. Whereas the cryophorus, these low-pressure systems, would be going from a sub-atmospheric pressure to an even lower pressure. Vacuum pressure, it would be the same vacuum pressure in the condenser for both systems, except a regular Rankine does a high-pressure to low-pressure steam. But the combustion system, and now most people would be like, yeah, well, now you have non-condensable gases in the system where the condenser won't be able to condense them and then maintain vacuum at the other end of the system. But what the condenser will do is, one, reduce their temperature, so that will play a part in it. But Tesla's high vacuum pump, that's where that actually comes in both the high vacuum pump patent and the I'm pointing over here because I've got the patents on the wall over here, the GB186083, the high pressure one. In the patent he talks about even this combustion system where you mix both the exhaust and the steam together. You can use them with the condensing system, or a plant with a condensing system. You need to use a better quality fuel. But after the condenser, I'll just take this down so you guys can see it. Probably work better. Even in this patent, Tesla has the high vacuum pump after the condenser. From a steam supply plant, usually you're supposed to let the steam come into the condenser, and then the condensate will go down the bottom. The second stage pump, he talks about how it's good for being able to help mitigate any leaks in a normal steam or turbine system, so that you're not bringing in, when you bring in non-condensable gases, you can remove them. But they're not just for handling leaks. When you run a very, very powerful high vacuum pump on the condenser, when using this steam and combustion system, this becomes the second stage of an inverted Brayton cycle. And just like you could run an inverted Brayton cycle from regular pressure, hot air, expanded into a vacuum, heat exchanger, taking the heat out, and then use a compressor to bring it back up to atmospheric pressure for a regular Brayton or inverted Brayton cycle, you can run from high pressure combustion to a vacuum condenser, take the heat out, and then run your compressor to pull it back out, bring it back up to atmospheric pressure. But you have to have the heat exchanger, the condenser, for it to be useful. Otherwise, you're just compressing and depressurizing. But if you have the heat exchanger where you can remove the heat from the system, you actually can get a Brayton cycle, and you can get a further higher thermodynamic efficiency out of it, and be able to expand even the non-condensable gases to a further deeper point. He says you need a really, really good pump, which obviously he's made them, and he talks in the patent that these high vacuum pumps are supposed to be like 18 or 20 inches in diameter and staged. So you can imagine that this is a big multi-stage high vacuum pump if these are 24-inch discs. And then, again, to follow up with this, flying here. The fuel tank and the compressor pressurizes the fuel tank, and then the fuel goes back into the air, or goes down into the air nozzles. This isn't like above, there's a break in the paper here. It's just to show that this is a separate location, and this is a downward looking view of this. But that pressurized fuel tank system is what I've got down here that I'm working on, and I'm doing the mix between liquid fuels, and I'm also running a propane tank in with it together, because he talks about basically any fuel can be used in this. Powdered coal, waste oil, crude oil even, propane, natural gas, syngas, hydrogen, whatever. If it's burnable, you can put it in here. You all, like, I'm really excited. I talked in another video about potentially we will be able to test powdered iron as a fuel source or a fuel storage chemical, because all the rust, when you burn the iron, the rust can be cycloned out of the exhaust, and you can use solar panels to run electrolysis on that rust and actually electrolyze it back into iron and oxygen. I'll put these where these block my view. I'm getting a little cold out here. Sorry if I missed your questions down here. Hey Matthew Simon, thanks for joining. And hey Held Lightning, thanks for the kind words. I kind of get back to work here, so I'm not stalling even longer. What was I doing? 2 fuels. Propane's got the check valve now. I need a check valve for the liquid fuel, so both neither can fill back into the other tank. Hey Jeff, welcome. Yeah, this is the first live. I was testing out the longer format earlier. The video I released earlier today it seemed to go pretty smooth. I thought maybe we'd test out the live. I'm not going to be here for too much longer tonight. I'm going to try and get this double fuel system going. At the very least, I can try and light up the propane. I'm not sure if I'm going to get the liquid going right now. That's going to take some tooling or messing around with it. Did I put these on right? Flow goes that way, flow goes that way. Cool. This has to come out. Well, that's not the right place to do that. Definitely not what I wanted. Go from here. Boy, do I love swivel heads. And there's going to be oil from here that I don't want to deal with, isn't there? Okay. Take this off. Don't do it. Don't get stuck all weird. It did. Yeah. North Coast Green Men. Yeah, I have that venting right into the space right now. It actually doesn't put out that much. It says do not install in confined areas with low ventilation like a bathroom. Um, this garage is about 900 square feet. My house is about the same. Actually, it's almost as big as my house. And I have the windows open when I usually run it. I have a CO detector in here as well, just to make sure nothing gets bad. And I've never set it off with that. And I've actually set it off once when I was doing tests with the other burner, and I had run isopropyl alcohol into it, and it did not complete burn. It immediately set off the CO detector in here. Did not like that. Yeah, man, it's definitely gonna work. That's the right one. But yeah, I don't know if I finished explaining that. Yeah, a lot of the exhaust off of here, you can kind of see it on the wood up there. There's a little bit of discoloring right here on this side and that side of this. That's why I put this little aluminum flap here, so that any of the heat that comes off doesn't go right up to the ceiling. I need to finish my ceiling here and get this paper insulation covered. That's gonna get dangerous if I do any big flames in here. But yeah, I can, when this thing is running, I can put my hand above here and it's not too hot. I can hold it there. What did I just put on there? Put that on there. What needs to go where now? I need to go liquid fuel to the bottom. Make sure I did this right for the 5th or 6th time. Yeah, this will work. Cool. Now, nice, yeah. Geothermal is another way to go with the vacuum steam if you can get that kind of temperature, I'm not sure how warm you can get that pond to be able to boil off of it. What are you going to be using for your condensing medium? The pond, or is that's what you're referring to? Do. Wish I could stream some music, but I don't think YouTube lets me do that unless I have special music that's authorized by YouTube. Which, if you have seen a bunch of my videos and you like the music, one of the main artists I've been using, her name's Bad Snacks. Check out her channel. I don't know her, I just really like her music. Okay, and now I'm getting warm again. Do. Nope, I need a 90 in there. That's getting awkward. Should I put a pressure reader on there too? I have one to do it with. Let's do it. That would get in the way, wouldn't it? Okay, well, for right now, we're not going to deal with that. Just going to keep tightening these up until they line up the way I want them. I need to go. Why am I not thinking straight? Alright, there we go. That's how I wanted it. Cool. Now I can put the propane on back. Remember, safety first. Which, coincidentally, safety usually means a clean workshop, and I don't have a clean workshop, but ignore that part. Hey R3D, so Tesla's combustion plus steam turbine patent, GB186 is there's a combustion, so fuel system I'm working on right now for propane and liquid fuels. Fuel throttle, this is the air input. I'll have an air throttle for doing air fuel mixture ratios. Combustion goes all the way through here. That'll go into a steam mixing tube. So before I go on that far, that combustion flame tube is sleeved in a water jacket, boiler, whatever you want to call it. And this in here, the boil, or the steam that gets made from all the heat lost, radiated off of the combustion sleeve, makes steam. That steam is then sent in to be mixed with the combustion jet to go into the turbine. I have a couple of videos. I'll put a link to the little more complicated version of what I've got here that's got a little more bells and whistles to it. that link I just posted in there is the video to the Frankenstein of what's sitting on the table here. I don't think you guys can see it though. It's basically this with the sight glass here, but a little bit different, but all the same. All the stuff is the same, and I explain it and do all the walkthrough so you can see it a little better. I believe I know what you're talking about, the nitinol heat engine. Could you? Which one? What do you specifically mean by that for recouping the heat? I have to look that up real fast. Oh, is that the wire that gets tighter? Yeah, like the nitinol gets tighter and then it like causes it to continue turning it, right? Yeah, okay, that's what I thought. Sorry, there's a little bit of a delay. I mean, yeah, I mean, I've seen it, I've thought about it. I'm not sure how I would put it in here, but yeah, I mean, it works. I don't have anything against it, if that's what you're asking. We're in business. I don't like how long this has gotten, but it'll suffice. I don't know if I like how tight off this has gotten. Feels like something out of Men in Black. Wait, need a gasket. Cool. All right. So yeah, I won't be using the liquid fuel tank for now. I need to make a second liquid fuel tank. So this will be for waste oil. That one will be for gasoline or diesel because the sight glass on here it's got silicone gaskets in here. It can't handle that. So yeah, it'll be waste oil, liquid fuel, gasoline, or propane, syngas, wood gas, hydrogen, whatever you want to call it. And then the next step after that will be doing the solid particulate flow in with the airline that goes in with it. And so I'll be able to do all 3 types of fuels at once if we really want to. Which would be really annoying and hectic to manage, but I'm sure I'll make it happen. All right, where are we at here? Propane tanks now ready to go. Maybe I should tighten that down. Be safe. Next. Yeah, I've got a regular full spark plug in this one now. Again, everything inside is stainless steel. These brass and this brass and that brass is the only thing not stainless steel now that's connected to the inside, but I'm not worried about that on this boiler setup. But nothing that's got flame touching it has anything but stainless steel or the spark plug. And I don't think the spark plug's made of stainless steel, and it's probably going to rust being in the boiler, but I guess I can only eat so much of my cake that I get to have at the same time. And I'm getting a little wonky with how many different layers and layers and layers I'm doing with this. I mean, realistically, I want to make it all anything brass, stainless, and I will. I just money. There's only so many I can buy, and I've got a ton of these sitting around here that's brass. Because if you can see, this table's full of them, full of stuff. But I'm just kind of trying to use what I have, and also I put some stuff together before other stainless steel parts came, and now I've got a bunch of stainless steel stuff, but I don't feel like reassembling some of this. I'm kind of annoyed because this thing's leaking right now. I think I might have damaged this 4-inch tri-clamp gasket, the Teflon one. Taking it off of this, again, you probably can't see it. And when I took the sight glass off, it should go back and fix itself once everything gets heated up, but it's kind of dripping water right now. Okay. I need to grab something. Be right back. Don't go anywhere. Alright, I'm back. Needed something to drink, my mouth is getting parched. Hey FunCon, apologize if I'm not saying that right. Turbo ramjet would be sweet. Yeah. Afterburner on here? But yeah, if you're not familiar with Tesla's patent, it's a GB186 083. How am I going to have to actually wait to see way this shows up on the camera, there's quite a bit of delay, although I'm sure this will give you some time to check it out. Hopefully I'm holding it right. Okay, yeah. Turbine, so compressor, fuel tank, compressor pressurizes the fuel tank, fuel goes down to here, so compressor, air fuel mixing nozzle, combustion chamber, spark plug, accelerator nozzle, steam tube, and then the steam mixing tube, and then that goes into the turbine. And then after the turbine, the exhaust goes through a boiler and makes more steam, so you don't have to fully utilize all of the heat energy in the expansion in the turbine. You can just recoup it and make steam with it. That steam is then readmitted into the steam mixing tube. You can either, he says in the patent, you can either put it in through here, you can put it in with the main supply, or you could just put a whole other nozzle on the turbine that it just goes through on its own. This is designed to also run off a steam supply, and you can't see it in here, but figure 2, the regulator, is right here in the center, and it has a steam supply coming up from the bottom of the whole rig, because this is a top-down view. That's the generator. The compressors run on an electric motor powered off the generator, so it's not. He says you could do direct to shaft or this. The whole system was supposed to be meant for like a cheap installation on like a ship or in like an already existing plant that already has supply compressed air and lines running around the ship and fuel lines on everywhere. Like, so it's something that's supposed to be like you already have these things in a regular ship. Here's the thing just to make electricity and then here's a way to recoup it. I have not tried directly using exhaust gases to run it. It should be, you can do it. I'm not sure how the flammability of them are, but I have not seen Robert Maddox's channel. Ramjets are sweet, so if he's building them, that's even cooler. Yeah, I'm hoping to be able to put this on get a version of this we can put in a motorcycle or go-kart. I'm going to start building some 6-inch square ones. We've got the 12-inch square with the 10-inch diameter. I'm going to do a 6-inch square with a 5-inch diameter set, just half size. Everything's just half size. A couple more discs out of it, maybe do 100 discs, 120 discs. But yeah, we'll be able to, I want to just do that as like a full electric generator, and then be able to just have these as like a recharge kit for electric cars, or literally be the powerhouse for an electric electric bike that has an electric motor on it. But you use this to supply the electricity instead of a battery bank. Which means you still need fuel. This isn't going to save the world unless you're using green fuel. So use it responsibly, guys. With great power comes great responsibility. Spider-Man's dad. Yeah, absolutely. Concentrated solar can work as well. That's what the kind of where we started with this whole venture. I want to use concentrated solar for storing the heat in a thermal tank, and that thermal tank can be used to boil vacuum pressure steam in the cryophorus vacuum steam system that I've got over here that will be working in conjunction with this. This will be a second or a parallel loop run from the waste heat off of this. We'll go to power that. But in the end, this whole high pressure, high temperature combustion plus steam can go to a vacuum condenser, and then after you condense all of the steam in the vacuum condenser, in Tesla's high vacuum patent and in this patent, he talks about after you put your steam into the condenser and you condense as much of it as you can, your condensate goes down. You have the second stage vacuum pump, which removes any of the non-condensable gases. And what that does is it makes it an inverted Brayton cycle then. So you can have a high pressure, high temperature steam plus combustion to a vacuum condenser plus vacuum pump, making it a Rankine inverted Brayton cycle. Yeah. With lots of thermal recoup. Insane Santa. Oh, I have seen him. He's the big beard guy. I've been served a couple of his videos. I haven't had a chance to actually watch them yet. Santa with jets. That's funny. Okay. Where was I? So I now have the liquid fuel hooked up. I have the propane fuel hooked up. I need to now get the air supply hooked up to both the pressure tank and, well, it's hooked up to the pressure tank right now, but I need a new air supply to this. I don't know if I want to, I have a T there. That would work. So many things to do around here. Or should I just do a quick line to it? Or just run the other compressor? One sec. Gotta check the other compressor. How much of a pain? Yeah, let's not do that, I guess. Okay. Not gonna do that right now. We're just gonna undo the liquid fuel tank for the time being. Turn that air off. Cool. Tank out of the way. Now, question, should I do a U? Do I have the stuff to do a U real fast? I do. Let's do that. These are 2 inches. 1.5. These are 1.5. And of course, I don't have a knife out here. Just rip it apart. Save the cardboard for shredding and fuel later. Got about 3 big old trash bags full of cardboard shreds for doing either, I'm going to start by gasifying it and using it in here, but then I'm going to try and actually mill it down to fine particles with like a grain mill. If you guys have a better idea than a grain mill, please share. I would love to hear that. But yeah, after I mill it down, I'm gonna try and do little entrain dust or the powder of the cardboard in with the air. Like just do a little actually sandblaster nozzle type thing. A little dropper. Make sure I have all the T or tri-clamps I need. I do. Cool. Now, I probably won't do this in the end. I just don't feel like figuring something out in the meantime. And I don't want any fuel that would, if any fuel did, I'm not using liquid fuel for right now, just yet. I'm going to try and do a starter or light test before I go. I want this to tee up before going to the compressed air line, so any fuel that may, if any liquid fuel could build up in here, it can't drain back the wrong way. I won't currently have a check valve from going back into the compressed air, but I will. Actually, I could put one in there. Why not? I've got a tri-clamp one, but I don't know if I have enough tri-clamp clamps to do that. 1, 2, good. I got enough. Cool. Let's take that back off and put this in there, just for safety, because I shouldn't have a way for that propane to be able to backfill into the. No, don't tell me this won't fit. Definitely won't fit. Well, what do we do? It'll be fine for now. Don't do this at home. Guess I could put it on the side. Turn this a little more so you guys can see. Can't tell. There we go. Oh wow, I got behind here. You guys are going ham on this. Yes, Tesla gas turbine engine. I have not seen anyone specifically do a Tesla turbine that has different or sequentially larger lobes, however you want to call them. I think that's a cool idea. I think that would actually be, so an interesting part is the Tesla valve works highest for like high frequency pulsed, or works best for high frequency pulses of air. The higher the frequency, the more it'll work like a diode. Very similar to a capacitor. So it's not very good DC regulator or DC check valve, but it's really good for pulses. But the lobes, it's my opinion that the lobes and the length of the valve will dictate what frequency it starts becoming effective at. And I think that doing those multiple or the different sized ones would give you like a wide band frequency for it to be able to be more diotic, or how, I'm not probably making up words here, but yeah, make it more of a check valve. Yeah, entrainment for the powdered fuels. Unless you add more heat to it, you're not going to make steam out of with the Tesla valve. That's something you have to come up with the energy for the latent heat of vaporization. Even if you have a mass of water that's pressurized and then you rapidly drop its pressure and it does boil off, you'll only be able to use as much as you can supply the latent heat of vaporization and then heat it further. So if you try and just use a valve, you won't be able to make it condense or boil without actually removing the heat. You might be saying that, and I'm not fully picking up what you're talking about here. If you're using the valve as the heat exchanger, and then those are the expansion or compression, not compression, but yeah, expansion stages. Yeah, oh, so you're using it as the boiler. Yeah, I mean, it could work, for sure. I think I can still put this in there. Hopefully it's not too heavy. I bought it to use it. One of these days I'm going to have a clean white sheet to be able to put all this stuff in front of so you guys can see it much clearer. I know it looks like there's madness everywhere, but I do in fact know where everything is in here. And yeah, this is a wholly excessive section for the time being, because I could just use one of these small check valves I've got. There's no reason this needs to be this big. I'm pretty sure this is a liquid check valve anyways, not necessarily for gas, but it'll work. Cool, one more. And don't tell me. Try my board. Okay. Yeah, I do like the idea of using the valve as a boiler. I have dabbled around with using it as a... I haven't thought about necessarily doing the multiple or the sequentially larger valves, but definitely for a boiler. There's no reason it shouldn't work well, or that you can't use it. It just might be not be a wholly necessary. As far as the gravitational power, I haven't quite figured out necessarily the right disc spacing and whatnot for the turbine to be done with water. I'm specifically using gaseous settings right now, if you will. But yeah, you could do that. However, you have to think about how much power you can even get out with the head that you can produce from whatever height you're pumping it up to. If you've got like, if you live on like a land that's got a pretty good slope and you can get a lot of height or drop on it, that's a good idea. But I forget the equation off the top of my head for power available for flow rate and or for like area of the pipe plus the how much height you're using or the head you're using for the potential energy. So we are, for the most part, good to go. Darn it. I did not think that through. I need the needle valve for the air supply. Oh, that's going to take a little longer than I want. I'm sorry, guys. I'm going to have to end it tonight then without doing a combustion test. I will be back again tomorrow. I'm just not going to keep working. This is going to take me too much longer. I might keep working tonight. I usually work late into the night, but I don't know if I'll go live. But yeah, thank you for joining me. Again, if you guys have any more questions, ask them down in the comment section after the live chat goes. Yeah, have a nice day, everyone. Not sure how to go off live, so we'll find out how to do that. You can watch me. Before we go, maybe I'll just do a quick walk around. You can see this. Flame tube comes through here. You won't be able to see down in it, but in the last video I elongated this. I made a longer chain tube in there, or flame tube in there. Not chain tube. The header for the boiler. This will go and mix what's over here in a bigger mass with my smoothie cup. I had taken the sight glass out of here, but so this is about the same thing you're seeing here, except this is a T or a cross on the bottom, and this one's a T. Flame tube goes down the center here. It goes into this steam mixing tube. I put another, there's a 1.5 inch tube that this 1/2 inch goes into here and then goes into another 1.5 inch, and that 1.5 inch goes out, and then this steam goes and mixes with it in there. That is, let's see, that's this flame tube mixing chamber there. And then this will be a complete, this inside here of this, because I'll make this come out of there just like I've got these coming out. Inside here will be completely sealed. I might do with a vacuum boiler in here and just use these, the heat coming off of there, as a vacuum boiler flame tube. However, I'm not sure. Might just run the exhaust from this back through here just to keep the heat difference between this and outside lower. We'll see. I don't know. But all right, everyone, yeah, see my messy desk? I swear I know where everything is, though. Maybe not everything, but all right. Fuel, pressurized fuel tank, propane tank down here. Propane in, fuel in, both have check valves. There's another check valve inside on that the fuel line that goes in, so then no air can go back. And I put this check valve here. But all right, have a nice night, guys.